Alright, this is the solution for problem 5 from the first super quiz. In this problem, we're given a differential equation, which you can see in the middle, and it is not a separable differential equation. However, after a substitution, we can make it separable. So we call this a separable differential equation. And they're asking us to make that substitution, make it into separable differential equation, and then solve the differential equation. Okay, which will then allow us to solve the original one. So, based on just the experience from our quizzes and our homework, it is reasonable to let our u be this quantity on the right-hand side of the differential equation. So if we do, then we could compute the derivative of u with respect to t. And, well, okay, the first function is a cosine, but not of t, but of y. So we have to use the chain rule. So this will be negative sine of y times dy dt plus 3, and then plus 0. Now, this negative sine of y dy dt, oh man, does that look familiar? That's just the left side of the differential equation, which on the right-hand side just equals u. So this entire complicated expression on the right is just equal to u. So our du dt equals u plus 3. So we started with a differential equation that was not separable, and we transformed it into one that actually is, because now if we multiply both sides by dt and divide by u plus 3, we'll get du over u plus 3 is equal to dt. Now the u's and the t's have been separated. Okay, now, as is our usual method, we'll anti-differentiate both sides. And when we do, we'll recall again, when you anti-differentiate both sides of an equal sign, you have to put a plus c. Okay, on the left-hand side, this is this normal game now. We don't quite have du over u, but it's not too far off, right? It's just composed with a linear function. So this will be ln of u plus 3. If we differentiate, the chain rule only gives us a times 1, so nothing needs to be changed. On the right-hand side, we get t plus c. We can now exponentiate both sides if we like, and we'll get absolute value of u plus 3 is e to the t plus c. As is usual, we'll break this up as e to the t times e to the c. We'll call this e to the c, which is a constant d. Again, this absolute value just creates a plus or minus situation. We can ignore that by just sucking the sign into the d. So u plus 3 will be some de to the t. Right? Then we'll subtract 3 from both sides, and we'll get u equals de to the t. Finally, well, let's see, what was our u? Oh my gosh, it was this craziness up at the top. So here, let's move this over to this side. So let me copy. U is equal to d. Oh, we forgot a plus or minus 3 over here, didn't we? U is equal to de to the t minus 3. And so u, I can replace it with cosine of y plus 3t plus 1 equals d e to the t minus 3. Let's leave the cosine on the left, put all the t's on the right. So I'll have cosine of y equals de to the t minus 3t, and okay, plus 1 moves over, becomes a minus 1, so we get minus 4. At this point, I want to stop, mostly because taking the arc cosine is going to create some more issues where, well, maybe we're not getting all the answers. So we're going to leave it at this step. Okay, and that's our solution.